Hello there. This is Friday. I am creating the 17th broadcast to nobody, apparently, that is watching me create a new JavaScript driven orchestrator through CouchDB, meaning that I can install software across a cloud of devices from Windows, Linux, full OSs to the Raspberry Pi, which is an SoC with an OS. I actually looked up things like the Pico. And I also got this. So JavaScript 4, and then there's JavaScript XS. No. Embedded. Anyway, I have a whole thing about a whole article that I can look back into that is basically going on to embedded boards. I plan on the first application of this in a week or two to be on music, so I did look into JavaScript synthesizer for Node.js and other JavaScript enabled backends mainly, but I'm sure I could probably cross compile it to run in the browser. And that was another one of those targets, was the browser for my orchestrator. And then based off this orchestrator, then I can write full programs for that I'm tagged, as well as like an OS. So you can tag your executable and it runs across those resources if they're available. And you can see kind of what resources are available right now in the OS later when I write it, obviously. So not just elementary, but there's also JavaScript, like web browser based synthesizers. Something like this. No. Tone.js. That's cool. That's cool. My tutorial. I like TinySynth. So why do I like this? Wait. That's cool. So I could play this, and then I have this buddy of mine. I'm gonna go look mom distributed computer now. Distributed OS. So yes, I'm a very big fan of this artist because he writes, or he writes with his soldering gun, drone synthesizers. So he's got like 300 of those wired up. So I could do it with those embedded systems for the cheapest. They're like $4 a board, and I could just write to all, use a switch or something, and then write to all the boards, and then just hit play. And I don't know, use some Wi-Fi or something for setting the values on them. I don't even know. I haven't gotten that far yet. Anyway, so where am I in writing this orchestrator? Well, I was letting this start up for a bit, but now I think I can start up the router to my database, which is CouchDB, which is just a JavaScript or a JSON database, JavaScript and JSON. So what this does is it tracks users. So you can see in here, I have a users, and I have, that's a user because it doesn't have a node. So a node to me in my API means computing resource, either one of those CPU, like a Node.js instance running, or some kind of managed, what's it called? Sandbox. So it's some kind of managed sandbox running somewhere that is managed through its own database for security. For now, I have not implemented security, but it is thought about a lot in my project. So that means that eventually, not very far away, is the point where the node doesn't really know the login for this user. It just, well, not all the nodes anyway. I'm going to have a trusted node where I know I'm safe to put admin credentials so that it can manage some things off a node, but is elevated privileges. And then the rest of the nodes is just knows about its own database, and that's it. So those two things are managed more or less. Okay, and then I can basically write packages of software that right now get deployed to what I call pods, or the instances of those packages that are actually running through the Node.js sandbox that I haven't really implemented yet. It's just, right now it's just a proof of concept that it is running, and I can scale up the number of instances per this node of this package. So I can deploy it multiple times. What else? So that's where I'm at right now. And then I want to be able to expose these packages in a standard way that I can then call the software that's running in the node, I can call it with requests. So the way that this is running off of Linux in Kubernetes or Docker, the other orchestrator that we have right now, and everybody in JavaScript, basically, I have a screenshot, but on LinkedIn I had this post where they're like all making fun of Kubernetes because it's not JavaScript, and JavaScript is the most popular thing in the world, and it's the most web technology, and that thing is the orchestrator that we have right now. Kubernetes is way too low level, and what they do is they use ports and no, and it doesn't make any sense. Why would you use ports and then they worry about files and then it's all data to me? So I'm going to create requests, like request objects through this orchestrator, and I'm going to run them through the database. And what I've done so far is I've created the basic requirements for getting those requests handled. So each user has its own centralized request for the routers, centralized request database, which is here. And then each node is going to have a database like this, which is going to handle the requests and responses for every resource available. And it seems like there's some duplication, but I really did my best to avoid a lot of the issues that could have come up. So it's only duplicated once, even though it's duplicated. I do have my, oh wow. So these things are still starting up, apparently. I'm thinking I'm going to take a quick break after I do this brief introduction. You can, if anybody's watching, you can go ahead and subscribe to us, just so you remember, because I will be going and recruiting soon. So in a week or two, I think, or 3, I will have the request done, and I will also have this web based speaker / synthesizer that will be a drone. Oh, look, it's running. That would be a drone, so people will be able to play with the whole thing, even though not all the features are working. The beta is pretty much ready to go. So that being said, I'll show you after I take this break. What I'll show you is how this replications. Why is the damn replications done? Okay, this should work. There's no reason why it's not. This is an old replication that. Oh wow. That has no reason why it's not working. So, because this is the pod and the node. Yeah. Okay, so yeah, there you go, it's running. So I'll take a quick break and then I'll show you exactly how the services are supposed to work and what changes I've done to make them work. And then I'll get right into writing the router, which is, I'll talk more about it after the break. Okay, I'm back. So let's go over what it takes to write somewhat performant requests. First of all, I had to assume that I'm still running on the nodes, so I haven't split off into deployed services yet for my, so the pods aren't running my core code yet, or like my trusted code that would need a user login. It's all running on the node. So that's the assumption. And what I did was I have here how many nodes I have. So that's the same as the number of routers that I'm going to have. And it's going to change, right? So when I go to a more secure model, it's not going to run on the node. It's going to run on the pod, these routers, on the trusted pods, on the trusted nodes. So it'll be somewhat more complex. But for now, I just want to write the beta code just to have it. Okay. So I have these two databases. So what I want to do is I want to write all my requests, even though it's somewhat of a duplication. It's for performance. So I want to write all my requests from the nodes service database to the user service database. So if I write a request like this, I need a source for it. So if I just save it like this, it won't be replicated. And the reason for this, actually, I'll show you. So the reason for this is because I want to be able to copy requests that are not the same source as the current node to some other node in order to have them fulfilled. So if the source is not the current node, then it doesn't get replicated back to the user because the request is there to be fulfilled, not to be requested. So if I go like this, then it gets replicated up to the user data. Okay. So then the router basically there's two modes that the router can run in. I'm gonna have here a is remote, and then when this is false, it will still get replicated just in case, but the router will have to wait for, the router will have to wait for the local, now that I think about it, it would also have to check if it's able to satisfy that request locally or remotely. So when I launch it, I basically know on the node if there's the pod that I want, because every pod, or at least the node itself, will know whether or not there's a service that actually responds to that request locally. So it will set that remote to false, and the router will just wait, and the local service will just say, okay, I'm assigned, I'll take care of this, and once it issues a response, nothing will get handled by the router. It all gets handled locally, and then if you put in true, then the router knows automatically it needs to route it at the user level towards some other node with some pod that is different than the current pod. So I'm also going to have is deleted. And that's going to be false until I delete it. And CouchDB works this way because once you delete something, it only passes an ID revision and maybe a deleted thing. And so every other database will be unable to use those filters to perform the replication. So if I do this, then I just watch for this change for it to be true. And if it is, I just issue the delete on a local level. And then nothing gets done when it just passes through the deleted change. So that's it for that. So that's saved, and then it gets replicated here. So I assume that the request only gets changed once, and that is when it's assigned, resolved, or deleted. So it's deleted at the source, I would say. No. Yes, it's deleted at the source when I finally get my response figured out. So there's two types of responses, right? Let's create a response. Is remote true? So if
when you unlock the power of premium, you're unlocking freedom. Freedom to listen to any song on demand on any device. The freedom to skip songs.
So whoops, this is a response. So you can see the response isn't replicated up to the user, but then if it's a response from the current one and it says it's true for a remote, it should be replicated to the user one. Okay. So then even if the remote is false, but the target is, so it doesn't matter whether remote or not. If something ends up in the user database with the target to my node database, then it gets copied over. So this is all in the replicators. So there's 2 from the user, 2 from the node request database to the user database, user request database. So that's response and request. And then 1 for the response, it goes from the response database to the node database. So the only thing I have left to do is write the 2 pieces. So I gotta put up my sticky and say is remote. And then is new. Time route is deleted, I guess. Because I don't need the time is delivered. I just go is deleted. So I just go to services. No. So I have a router service and a requester object. Request object. And I also have a response object. So router service cares about this request like this. Actually, it cares about everything, so. Okay, so yeah, that's that. And I get to port everything over to the browser, including the trusted node services, because they pretty much do everything the same on the browser, except for looking through the file system as well as using the environment preferences as well as the actual sandbox and how it's run. Okay, so what I've always said is that I use the copyright-free music playlist from Bass Rebels. I think I only forgot it on one episode, so there's your credit. My only thing about this is if I create a request object, then I have to check whether or not, I guess I could add a flag and I could check whether or not it's actually guaranteeing me that the service I want to check, I want to create a request for. So if I have a request, if I have a router service, I also want to have a request service. Because it'll keep up the database connection and it will request a certain kind of service. So it will create the request object, add it to the database, and handle the response, handle the add request, and then it'll return a promise with the response. So you get to create a certain kind of request service with some database, and you can pass in what your pod supports, I guess. I guess the router could ultimately check later on whether you allowed it or not. I'm not going to worry about it too much right now. So it's waiting for responses, and then if my response came back, then I fire off that reply. Okay, let's do that. So first, I could write a router service though. That's the hardest part. That's the hardest part. And then if I put a request in my user, then it routes to the appropriate node. So let's see. I have updated the node config. Pod config. Package config? Okay, so for each package, I know how many instances of nodes of pods are running on each node. So now I fixed the bug also on how many pods are running at the same time. Here. So I can look at these, so I can start running my service. Is service true? So I just changed this. Okay, it's not right. Just for testing purposes. The other one is more for information on the pod, whether it's a service or not, for local information. I don't actually need it right now for the router. Okay, so I guess I'm gonna have to start writing this damn router. Talk too much. My voice hurts. All right. So, in the edge, it's going to be a new service here. So later on, these pod, I don't know about these, but I think the one I'm going to write, just about to write, and the volume one. So the part where I create databases for users based on what they request, based on their own information. I think I might have to run that through a service even. It sounds like the simplest thing, right? So the user puts something in their database. So it's something in here that says volume config, and it actually gets turned on by their own trusted service. It gets turned into a request to the core service. So a different user generates a request for a volume that basically gets answered by some service running for admin, and admin basically creates their database as a service response, and then it sends true or I created the database for you, and here is the credentials maybe, or maybe if they're provided, I don't need to do that, and also the pricing plan or how much it's going to cost, things like that. So the volume I could have implemented as another port, but I'd rather it's like one of the simplest thing. So I'm gonna reserve that for a really great, simple first spike or first example of a service of an admin service that runs in a core in the core pod. So when I run this, you saw here it already deployed a core pod. So as part of this core pod, I could run a volume create service that's going to have to wait until I also do the sharing. Where's the sharing? Volume. Okay. Replicate local DB with attachments. I like progressive. Okay, so yes, right here. Something like that. So that's 1.5 quarters, 4.5 months, right? So this is like till middle August, August 21st, some 22nd, something like that. So 17th, 18th, 19th. So something like 3 weeks in of broadcasts, I will have Beta 0.8 with the first example browser. Okay. So now that's done. I went through that, so let's create the service, which is also going to go into a pod later on. So this is going to have to be somewhere here. The service, the router service to a pod, perhaps. Definitely gonna need help on all of those. Already fixed this one. Cool. So obviously this is after. It's gonna take me another quarter, I guess. The whole thing. So 2.5 quarters, and I'll basically be done. The beta for the most part. Use on user. Yeah. Anyway. Okay. So new file. Okay, so Node Bootstrap is a simple one. No, it's not. What about this one? Okay. So, router. Ooh, what's wrong with this one? Okay, this doesn't need that. See, guys, it really does help to copy code. Isn't that funny? Okay. I definitely need a lot more of those. Do I even need to delete all? No, I really don't think I do. Because it issues a delete on. No. And I will need this node DB schema eventually because, wow, because I'll need the node configs of everything. Now I have those. So I need to request. So I have everything in my user. I guess I would need a service DB schema. So I need and responses. The requests and responses are all I care about in my router. And what I think I'll do, where was it again? In user config? Right, so in user config, does it update? Yes. So it initializes. Right. We fix this region, then I'm gonna take another little break. That's better. More lumbar support, Captain. Oh, it's a new day. That makes all the difference. Oh. So does it emit the change? Yes. Okay. Just gonna double check here. I know. Why are you always copying code? I forgot the async. That's why. Normalize some code and when it's changed, then I'm gonna have a value. So it's gonna be called router index. Or it's just gonna be the router yeah. And then router index is because this runs on the node anyway. So I do need the node config. Okay. And schema. It looks silly now. Just wait till we optimize. Well, so the router index is dot do, 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 do. Cool. So it keeps updated. Cool. So it keeps updated what the router situation is, meaning that it will skip certain requests in order to balance between the routers. So I'm going to load balance these router instances. Meaning that I have to create some kind of derivative stat of this index. So if it's every second, node user. Did I ever copy over the node user? I don't think I did. Okay, so I guess this is all. This is all a different section. Like so. Meaning that I need a constant here. How do I even make a constant in TypeScript? Constant. I can barely remember my own API when I'm programming. How can I remember all the programming APIs, especially when they upgrade like every other year? We're on ES8 apparently. Apparently there's dot values. There's ES8. I don't care. I don't care which ES it is. As long as the latest TypeScript that I have is working with it, there's too much information. If anybody asks me this at work, which I'm creating, so it's not gonna happen. But if I was working for somebody, and I was being so slaved that they asked me ES8, what's ES8? What features was the change log for ES8? I basically tell them I'm done with that. This is funny though. Const. Okay, say with const. What's the difference between TypeScript and JavaScript? I don't know anymore. Like I use them, you know. I try to use them the best I can. When it changes, I'm hoping that people update the damn Stack Overflow. You know, especially with the updated auto coding tools. Like they should automatically just say, okay, you see this piece of code, like copying arrays, for example, you just do it like this, right? Don't do it like the other, jQuery and all that. You can just replace. I'm excited by those coding tools, but they're not exactly a programmer, like everybody says. I'm excited about AI, but it's not exactly intelligent because it's just distributed stats that pretends to be neurons, which is like the lowest form of neuron. So this constant, actually, I think I'm gonna just create a new private here. So I have to do this twice. Hold on. Okay. Okay, so self dot Okay. So what is the constant? Const static or static const. I don't need this. And what's it called? Half a second millisecond wait equals 500. Class member. Really? So if I put it here, is that global? I'm so confused. Let's see. Oh, cool. I guess I'll just use that. So if I go router wait, which so I divide it by some number, and then I do a mod the other one. So let's see. I can close this region and basically when that constant comes in, I think this is okay. And then private is available balance. And it goes request time route, so time new So this is return in milliseconds. Request time over this is bool over this dot router index. It's not just router index. It's also number of routers. Okay. So this dot number of routers. So this is mod, right? Times so this is gonna be an integer. Let's actually divide. So let's say 1812 mod 3 times 500. Okay, so divided by wait, number of routers. Okay, so this was 28. So 38. No, there's got to be a mod somewhere. There's got to be a mod. Let's see. Divided by 500, right? Mod mod 3. Two, oh, one, two. Okay, so this gives me from 0 to 3 inclusive, which means if I go 3 minus 1, it's about the same, which is good. So it works in smaller increments. So if I go 100, 0.2, 600, 1, and then 1200. All right, okay. 1.2, 900 till 2. Okay, so 0, 1, and 2. So this is plus 1, I guess. But no, this is good. Okay, so this is how it is. So 1900, yeah, it's the same. Okay, so request time is this one. Number of milliseconds waiting, this one. This one. And equals this dot router index. Why? Oh, is it number like number? Is balance available? So it rotates the router every half a millisecond. So if I put 2 in that spot, then it'll stop responding to every request, and that's the test. Or if I put 3, it'll stop responding less and less because it's balancing with the other ones. Yeah. The only thing is if one of them dies, oh well, so sad. Half the request won't get answered. Okay. I once had a situation where the guy was trying to program something so that it falls into the same router, and I was like, why you do this like that? It's the most backwards thing yeah, it's crazy. Anyway, so to check for changes on those databases. So check for changes on the user's service databases, all of them, which is why I kind of want to have service objects, but maybe not. Who knows? So in here, for each node, I'll have one of these. And I'll use the same admin user to log into them. So this user DB now, which it's using these, so I guess it's gonna be like this. Oh, and I can get my own node DB here. No, I can't. Can I not? I guess this is the thing that does the, yeah. Let's see. Node conf. Okay. So services is going to have a DB, a watcher. No, it's not. Why would I need a watcher for? A DB. That's just so I can. Yeah, it's just the DB. So I can write the request to it. Oh, cool. Um, okay, so for each node user, for E6, 3. So node config for E. Okay, so that's the user, right? So I'm gonna go over the node configs in my user database. Now, node config is in shared, right? Wow. In Edge. Right. Okay. But node user, yeah, because they both load from the environment, which makes sense. Okay, I guess I'm gonna have to do a loop. Docs. So mode no. I'm just gonna get all the node configs. Think like that. I'm not even gonna bother with the objects because it's a one time. Actually, no, it's not. Hmm. Hmm. So I need to tell me when the nodes change, whether I have anything new. Or deleted. Okay, so there's a NodeDB. So here, NodeDB. There's a package. Nodes. And then like a pointer, like a current pod pointer for round robin. Oof. A week or two, I'm gonna be glad when this is over. So there's service DBs. So on change. Oh, and this is another thing, is the packages do have this, but sometimes they won't, like the node itself may not yet be existing or have a node config, I guess. So it only goes over the nodes that do exist. Okay, so the way I do this is I'll have each name in here. So I'll check this one, and it'll be indexed by node DB, by the node name. And then what I'll do is I'll separate this into something else. And then it'll keep going down. And then when it's done, I'll have to reset the pointer. I guess I could do it as an array. Or maybe even here. This is current used currently used pod. So this will be a data structure that is indexed by service, package, and then by node, skippable. If there's no node, okay, and then pod number, node skippable pod, and then these will be a tuple. Tuple, pod number, current pod. So current pod is bigger or equal than pod number. Implies that current pod equals 0. Okay, so every time a node config gets deleted by ID, I want this. So I want this by, what is a no name? No name. Oh, right, because that's the username that gets converted into the access. So by ID. So if it gets deleted, but then I can't look up based on name. Based on name. What do I want based on name? I don't really care, right? Node config ID. So it gets created or it exists. I add ID and I add the database connection. So I can just do it by ID. It's fine. So it looks down the node IDs and it checks. So it goes down here by service and then it goes by node name. That's why. So it goes by node name. Code. Because I have the name here. So I need another lookup to tell me the ID in case of deletion. So it goes, if it's deleted, it deletes out of there, and that's the only thing. Okay. DB's IDs. Okay. And I also need to watch the routers. I do watch the routers, okay. Okay. So how do I initialize this? I go over the configs and I update on the changes. So here I'm going to call it something else. Initialize the state. The router state. And updates. Okay, so That should work. I am gonna take a break. Man, I hate it when I have to put object code in my service. Oh well. Mm. Realized I forgot the damn routing. So here. Math.round. Right, this is the second. Okay. So it splits. Cool. So there it is balanced. Okay, let's try. Yeah, let's do it like this. And we have add so let's see. Um, that's better. Let node configs equals this dot userdb dot find node configs. Right. So these are nodes. Maybe once to do okay. So node configs, I have them. And then I'm going to also watch for changes. I'm going to create the database. Or no. Do I create the databases? No. Or after. The router starting up. Router starting up, and I want to watch for changes, specifically additions. I don't want to miss any. Node config doc. So here, I'm going to do this, watch for the changes before I actually get them. Unlike a lot of the other things. Maybe even to do here. That's a good place to notice that. And I'm gonna have another little break. Maybe not. So. Node watcher. Node config. Oh no, what happened to my paste? Okay. So I'm going to create the database. Parse ID. Oop. Parsdoc ID. Dot. At node name. Okay, so that should be it. Dot ID equals name. Um, I'm gonna have to initialize it. So that if it's a double, initializing, actually, I'm just gonna create this beforehand. State. Logs in. And there's your databases. Let's hope there's no race conditions. Yeah, okay. So there's not, and it creates two of these. Oh wow, I don't even need these. That's cool. Unless, yeah, if it's only one, I don't need it. And now I'm gonna have to do the same for packages.
Step into a world of music made just for you. Premium is your music, your way. Keep listening, and once we get to know you, we release new mixes based on what you love. From daily mixes to discover weekly. Premium lets you download those playlists and listen offline. Plus, enjoy ad-free music. Upgrade now to unlock Premium. Tap the banner to learn more.
Hmm. Yeah. Get. Wait. I know what this is doing. Okay. So that's the packs. And I'm just gonna clear the request. They're not likely gonna be valid anyway. I guess I could just respond to them. So I could resume the service. That's the beauty of using a database. You can resume all your cluster state without any network interruption. All I forgot was this. I don't need that. So it's gonna increase the pod, and then when it gets to a pod that is bigger, it skips it for now, and it goes to the next one. And then when it gets to the end, it goes back to the beginning. Okay. So here, I'm just gonna write these. And delete is also a function. Okay. Sad song. Okay, break time.